Okay guys, this is primarily for what you guys are doing on Friday. I want to give you guys a few examples of the free body diagrams. I'm going to be working through the right side and the left side of the page and letting you guys do the other two columns. To give you examples, make sure that you guys are staying on track. Okay, then you're also going to do these, and I'll be doing the right sides of those also to give you guys some clues. More of those. I'll do the first problem of these for drawing free body diagrams. All the way through page 18 is what you guys need to have done for Monday when I return. So it's a lot of work, and you guys need to keep the nose to the grindstone because this is going to be a pretty heavy workload for you guys, and so I need to keep you guys on task. The sub is going to have all of the answers, so when you guys finish, I'll allow the sub can show you what all the answers are, so you guys can correct them. Right. So here we go. For the free body diagrams, remember we're looking for all of the forces that we're going to draw. So the first thing we look for are if we have balanced forces or unbalanced forces. And then we're going to label which ones those are once we've identified whether they're balanced or unbalanced. So, a physics book rests upon a level table. All right, so this is talking about the physics book in particular, and it is at rest. Well, if it is at rest, that means the forces are balanced, and so it has no, so there are no unbalanced forces on it. It's not accelerating, and so it's going to be still. And so in this case, now, because it's on a table, it's always going to have a gravity acting on it, but it will also have, in this case, an equal length, remember the arrows need to be the same length, force pushing up, and if here's our table, that is a surface, and the force that is perpendicular to the surface of contact is called our normal force. So we would have N, or you could call it F norm, and Fg. Okay, so here's the next one. So that was A. So here's D. A sledder has reached, it's already there, the bottom of the hill, and is coasting rightward while slowing down. Okay, so if they're slowing down, that means that they are decelerating, and if there is any kind of acceleration whatsoever, it is an unbalanced force, and so we're going to need, so it's coasting rightward, which means velocity is in that direction, but that's not the force. If it's slowing down, that means the force must be in that direction, and that's going to be our friction force, so we'll call it script F over here. But if it's also on the ground, then you're also still going to have force of gravity and normal force due to being on the ground, and those two have to be the same length. Okay. For the next one, or next two, we'll put them both on here. Okay. The brakes are applied to a rightward moving car, so the velocity is still that direction, and it skids to a stop. Slowing down, skids to a stop. Those are pretty much the same thing. So, we're always going to have gravity, unless it says otherwise. If we're on a surface, we're always going to have normal force. And then if its velocity was that way, and it skids to a stop, the force must be in that direction, and that would be our friction force again. Okay, and finally, an elevator is rising at a constant velocity. It is not touching the elevator shaft. Constant velocity tells you what? Balanced forces. So, it is not touching the elevator shaft. So, that should mean no friction. So all of it's doing is rising at constant velocity, an elevator is going to have the force of gravity, and it is going to have something pulling it up, but elevators hang by what? How do elevators climb? Okay, they hang by cables, and so they're going to have a T for a tension. And that's it for the front page. All right, so check those. Those are examples. Okay, and you should be able to use those as examples for the other ones on the page. We're going to go on to page 16. Okay, now this is Newton's second law. Remember, Newton's second law is F equals ma. So our directions. Free body diagrams are shown, so they give us the free body diagrams. For a variety of physical situations, use Newton's second law of motion, sum of F equals ma, m times a, to fill in all the blanks. All blanks. They all need to be filled in. Use the approximation that g is about 10 meters per second, or 10 meters per second squared. And that's, is about that. So, the force of air, force of gravity. Those are balanced forces because they are equal to each other. All right, which means the sum of the forces, if they're balanced, that means that the sum of our forces equals 0. So down here, this is going to be 0 newtons, which means our acceleration is going to be 0 meters per second squared. Okay, but we can still find our mass because we know that F grav, force of gravity, equals our mass times 10 meters per second squared. Well, if our force of gravity equals 0.10 newtons, we divide by 10, and our mass is going to be 0.01, not newtons, kilograms. And that's how that works. So here's our next one. We look at this, we have a force up, force down, those two are equal. So in those direction, in the up and down direction, we have balanced forces. But over here, we have a force to the left. This is unbalanced. Therefore, the sum of the forces equals mass times acceleration and does not equal 0. So, the sum of our forces is going to be 9,000 newtons. Our mass, force of gravity, equals 10,000 newtons. We always find our mass from our force of gravity, and it's going to be our newtons divided by 10. So that's going to be 1,000 kilograms. And then our acceleration is the sum of our forces, 9,000 newtons, divided by 1,000 kilograms, which will equal 9 meters per second squared. This is really rather straightforward on how to do this. Okay, the last one on this page is given this information. So the mass of the cart is 15 kilograms. The acceleration is half of a meter per second to the right. So the total force is going to be 0.5 times 1. So there's an acceleration, so we will have a force, an unbalanced force, and the sum of our forces is going to be 15.0 kilograms times 0.5 meters per second squared, which is going to equal 7.5 newtons. 7.5 newtons. The unbalanced force in this picture goes right here. It's the dog pulling on the cart. So that's going to be 7.5 newtons right there. But we also know that our mass is 15 kilograms. If our mass is 15 kilograms, then we know that our force due to gravity is 150 newtons, because Fg equals mass times gravity, which would equal 15.0 kilograms, times acceleration due to gravity, which is 10 meters per second squared, which equals 150 newtons. And if that is balanced, F of gravity is balanced with the normal force, this is also going to be 150 newtons. So that's how you do that side. Now, you should be showing all of your work on these problems. These guys over here need you to show all of your work on these problems. Okay, I'm not going to give you credit, and I won't give you your stamp until you have shown all of your work on all of them. And they all need some work. Okay, next page. Okay, so I was going to do the first two of these for you. So, the first one is a 1 kilogram book is at rest on a tabletop. So diagram the forces acting on the book. All right, 1 kilogram book at rest on a tabletop. So we've got force of gravity, normal force, okay, and there's no forces in either direction. So, okay, bad example. We need to read the instructions. For the following situations, draw a free body diagram, FBD, in which you represent the various forces which are acting upon the objects using vector arrows. Vector arrows. Label each arrow to indicate the type of force, normal force, gravity. Determine the magnitude of all forces and fill in the blanks. Okay, this is a 1 kilogram book at rest on a tabletop. The forces are balanced, so the sum of the forces in the x direction, there are no forces in the x direction, is going to be 0. The sum of the forces in the y direction equals normal force plus force of gravity, which still equals 0. If the sum of the forces equals 0, then there will be no acceleration. However, we still need to determine the magnitude of all forces and fill in the blanks. So, force of gravity, remember, equals mass times gravity, which is going to equal 1.0 kilograms times 10 meters per second squared, which equals 10 newtons. Equals 10 newtons. And because the sum of the forces equals 0, this is also going to equal 10 newtons. 10 newtons up, 10 newtons down. Technically, this is 10 newtons plus a negative 10 newtons is going to equal 0. Okay, number 2. A 5.0 flying squirrel is flying from a tree to the ground at constant velocity. Consider air resistance. Diagram the forces acting on the squirrel. Okay, from a tree to the ground, so it is traveling down at constant velocity. Constant velocity should tell you what? Constant velocity should tell you balanced forces. So if we have balanced forces, that means we know we've got mg going down, and we have the force of air pulling up. But if they're balanced, that means that the force of air plus mg equals 0, and our acceleration, constant velocity, means acceleration equals 0 meters per second squared. There's no forces side to side, so that's going to be 0 and 0 meters per second squared. Our mass is 5 kilograms, so that equals 5.0 kilograms times 10 meters per second squared equals 50 newtons, which also means that our force of air equals 50 newtons. Okay, so that's it for the free body diagrams and figuring out from there. We need to do each of those. And I will even do one more on this page for you guys. All right, I will do, I'll do number 8 for you guys. I lied, I'm going to do number 5 for you guys up here at the top. So, a 2.0 Newton force is applied to a 1.0 kilogram book in order to move it across a desk with an acceleration of 0.5 meters per second squared. Okay. It doesn't matter which direction it goes, but we're going to have an acceleration across the desk. So it's going to be in the x direction. We have acceleration, which means unbalanced forces. So if we have unbalanced forces, we need to draw our forces. 2 Newton force is applied. We'll go that way. This is a force applied equals 2.0 newtons. We have the force of gravity equals mass times gravity. We have normal force because it's sitting on a table. And we have friction, which is acting counter to the applied force. Okay, so what do we need to find? We know that we've got a sum of our x forces. Okay, to the right is positive, which is going to be 2.0 newtons plus friction, are the sum of our forces. That is going to equal mass times our acceleration in the x direction. We still need to find that. The sum of our y's is the force of normal force plus our mg is going to equal 0 because it's not accelerating up or down. Here's where we get tricky. We know that the mass of this is 1 kilogram. We know that the acceleration is 0.5 meters per second squared. So the acceleration in the x direction is 0.5 meters per second squared. However, what we don't know is what our friction is. So we're going to use this equation and this acceleration to figure out what friction is. So our mass times acceleration is going to be 1.0 kilograms times our acceleration is 0.5 meters per second squared equals our friction, which we don't know, plus 2.0 newtons from our force applied. We're going to solve for F. So this is going to be 1 kilogram times 0.5 meters per second squared. So I'm going to have to continue this on here, another page here. So So that will become 0.5 newtons equals our friction plus 2.0 newtons. So we solve for this, so we subtract 2.0 newtons from this side. And we're going to get a negative 1.5 newtons equals our friction. But the negative just means it's pointing in the opposite direction. So our friction equals 1.5 newtons to the left. And then mg and then our gravity and normal force are easy. That's our mass, which is 1 kilogram times 10 equals 10 newtons. And this also equals 10 newtons. And that's how you do that one. And that was, okay, it's a little involved right there. But that's your walkthrough for number 5. And that is your page 18. And as I said, I will be giving all of these answers to the substitute who can show you these answers on Friday. So, or today, because he's going to be showing this to you today. So, good job, you guys. And actually, he won't give you all the answers, but he can, if you get through this, he can give you some help. So, I will post the answers. Well, we'll be going over this on Monday, so he may or may not have the answers for you. All right. We'll see you guys Monday. Have a good weekend. And this is P-Dog signing off.